Hey guys, welcome back to today's Geek for Geeks POTD. So today's problem of the day is predecessor and successor. So we will be given a BST and a key. So we have to find the predecessor and successor of that key. Now predecessor will be a number just smaller than the key and successor will be the number just greater than the key. So for in this example, the key is 65 and the predecessor is 60 in this binary tree and the successor is 70. In this example, the number which is just smaller than the key is 4 and number just greater than the key is 9. So therefore 4 and 9. So how you can approach this? Now we will take the help of the binary search tree. In a BST, all the nodes to the left of the node are smaller and all the node to the right are greater. So we will take help of this property of a BST. So if the node where we are currently at, if its value is smaller than the key, then we can say that okay, it can be a potential predecessor. So we mark it. Okay, we created a array list and an array of nodes so that we can keep the predecessor and successor. So if the root value is smaller than the key, so we mark it and go towards the right. We go towards the right because now we have to find the successor, so we need a bigger value. We can't go to the left side because we will obviously get values smaller than the root, so we go towards the right. Now we come here. Now the current node, the value is greater than the key. Okay, so therefore it can be a potential successor. So we mark it and then we go towards the left because now we need a value smaller than the successor. It means we have to check that okay, is there any better predecessor than whatever we have. So we go towards, we mark it the this one successor and we go towards the left. Now we come here 60, which is smaller than the key. So therefore this scenario we mark it as the predecessor and we go towards the right. So it becomes null. So at the end we insert the predecessor first and then the successor and we return the result. Now we have checked what will happen if the root value, node value is smaller than or greater than. But what if we find a value which is equal to the key? So let's say in this example the value is key, the value is 8 and the node value is also 8. So in this case, think simple. Okay, the predecessor will be whatever the greatest to the left and the successor will be whatever is the minimum towards the right. Why greatest? Because all the nodes towards the left will be smaller than the node, and whatever is the greatest value, it will be the nearest one, right? And in this case every node will be greater and whatever is the minimum, it will be the nearest one. So like that we say that okay, we check that if root dot left is not null, so we first go towards the left and we keep going towards the right, because towards the right only we'll be getting the maximum one. So we'll take a while loop and we keep on going towards the right, and whenever we come to the end we mark it as the successor, because that node will be the greater one among all the nodes. Similarly, if we have to find a minimum of the right, we first go towards the right and we keep going towards the left, because towards the left only we will get the smaller value. So we keep a while loop and we keep going towards the left. So at the end we break from the loop, because since it is equal and we have to find our predecessor and successor, we break it, and ultimately we add it to the array list and return. So this was the approach. Please keep solving, try to do it by yourself, and please like and subscribe if you have find any value, and see you tomorrow on another POTD. Thank you.